Work and energy feel like completely different ideas. One is a process, pushing a box across a floor. The other is a stored capacity, a stretched spring waiting to snap. Yet physics insists they are dimensionally identical. Add torque, the twist of a wrench, to that same list. All three of these wear the exact same dimensional fingerprint, mass times length squared times time to the minus 2. How can three different things share the same dimensional DNA, and what does that tell us about the universe's bookkeeping? Look at them up here. Work, the effort of a hand pushing a box. Kinetic energy carried by a moving ball. And torque, the twist of a wrench on a bolt. Three completely different ideas, yet their arrows all converge into one single box reading mass times length squared times time to the minus 2. To understand how three things can share one fingerprint, we first need to learn the alphabet they are written in. Every measurable quantity in mechanics is built from just three base dimensions: mass, length, and time. We write them as capital M, capital L, and capital T. The square brackets mean dimension of, so the dimension of length equals L, the dimension of mass equals M, and the dimension of time equals T. These are the base quantities. Everything else is a derived quantity, assembled from products of powers of these three. And remember, dimensions are not units. Dimensions are abstract. ML and T units are concrete choices like kilograms, meters, and seconds. Let's build velocity from the ground up. Velocity is distance divided by time, measured in meters per second. In terms of dimensions, that's L divided by T, which we write as L times T to the minus 1. Now stack force on top. Force is mass times acceleration, and acceleration is velocity per time. So its dimension is L times T to the minus 2. Multiply that by mass, and the dimension of force becomes m times L times T to the minus 2. Notice how each quantity inherits its dimensions directly from the one before it. Now the payoff, kinetic energy, is 1/2 times mass times velocity squared. When we look at dimensions, we ignore the 1/2 since pure numbers carry no dimension. So we have mass times velocity squared, which is m times the quantity L times T to the minus 1, all squared. That gives us m times L squared times T to the minus 2. Now let's do work. Work is force times distance. So that's m times L times T to the minus 2 multiplied by L. That gives m times L squared times T to the minus 2. The same fingerprint. Work and energy are dimensionally identical. And finally, power, which is work divided by time, becomes m times L squared times T to the minus 3. Here's a reference table of common mechanical quantities. Angle is dimensionless, a pure ratio. Area is L squared, and volume is L cubed. Frequency is T to the minus 1. Velocity is L times T to the minus 1. Acceleration is L times T to the minus 2. Density, which is mass per volume, is m times L to the minus 3. Momentum is m times L times T to the minus 1. Angular momentum is m times L squared times T to the minus 1. Force is m times L times T to the minus 2. And highlighted together, work, energy, and the torque all share m times L squared times T to the minus 2. Power adds another inverse time, giving m times L squared times T to the minus 3. Finally, pressure is force per area, which works out to m times L to the minus 1 times T to the minus 2. Now that we can build any mechanical quantity, let's turn the tool around and decode the constants hiding inside physics' most famous laws. Start with the gravitational constant capital G. Newton's law says force equals capital G times mass 1 times mass 2, divided by distance squared. Rearrange to isolate capital G. Capital G equals force times distance squared, divided by the product of the two masses. Now substitute dimensions. Force is m times L times T to the minus 2. Distance squared is L squared. The two masses give m squared in the denominator. Multiply out, the m in the numerator cancels against the m squared below to leave m to the minus 1, and the L terms combine to give L cubed. So the dimension of capital G is L cubed times m to the minus 1 times t to the minus 2. Coulomb's law has the exact same structure. Force equals 1 over 4 pi epsilon naught times charge squared divided by distance squared. The constant 1 over 4 pi epsilon naught plays the same role that big G did in gravity. Isolated, it equals force times distance squared divided by charge squared. Dimensionally, that's force times length squared over charge squared. It's the same inverse square skeleton, just with different physical actors. The structure of the law dictates the dimensions of the constant living inside it. Now let's turn to a quantum constant, Planck's constant written h. The energy of a photon equals h times its frequency. That is, E equals h times f, rearranging, h equals energy divided by frequency. Energy has dimensions of m times L squared times t to the minus 2. Frequency is 1 over time, so t to the minus 1. When we divide by t to the minus 1, that's the same as multiplying by t. So the dimension of h becomes m times L squared times t to the minus 1. Notice this is simply energy multiplied by time. It's the same recurring move as before, but this time it reaches right into the heart of quantum mechanics. Notice the pattern in all three derivations. Isolate the constant, plug in dimensions, simplify. That single move clears up three common confusions. First, constants are not just numbers. Capital G, the constant h, and the factor 1 over 4 pi epsilon naught all carry real dimensions, dictated by the equations they inhabit. That's why their numerical values change when you switch unit systems, but their dimensions never do. Second, dimensions and units are not the same thing. Dimensions are abstract, the symbols m, L, and t. Units are concrete, kilograms, meters, and seconds. Third, sharing dimensions does not mean being the same thing. Work and the torque both measure mass times length squared times time to the minus 2, yet work is a dot product and the torque is a cross product. Dimensional identity signals a relationship, not equivalence. Zoom out and dimensions become the universe's grammar. Because every valid equation must be dimensionally consistent, dimensional analysis works as a built-in error checker. It lets physicists guess the form of unknown laws and underpins every system of units. Return to our opening puzzle. When work and energy share a fingerprint, it reveals a deep truth. Work is transferred energy. And when we decode the dimensions of G or H, we're reading the structure of the laws they govern. Three letters, M, L, and T, quietly encode the entire architecture of physics.